Hi, I'm D and I'm from DBE2B01. I'll explain about the introduction to numerical integration and how do we define numerical integration by itself. It is actually an approximate computation of an integral using numerical techniques. The definite integral fx dx b to a represents the area between the curve y equals to fx and the x-axis from x equals to a to x equals to b. So even if integrate fx dx cannot be found, an approximate value for fx dx a to b can be obtained by evaluating the appropriate area. There are two methods for finding the approximate value by using trapezoidal rule or the Simpson's rule. But for my part, I'll explain the trapezoidal rule. But first, let us look into why do we need numerical integration. For the need of analytical integration, as it may be impossible to integrate tabulated data rather than known functions, and if the integrand f may be known only at certain points, such as by obtaining samples, a formula for the integrand may be known, but may be difficult or impossible to find an antiderivative, which is an elementary function. Or it is possible to find an antiderivative symbolically, but it is only easier to compute a numerical approximation than to compute the antiderivative. That may be the case if the antiderivative is given as an infinite series or product, or if its evaluation requires a special function which is unavailable. So let me explain what is the trapezoidal rule. It is based on a Newton-Cotes formula that one approximates the integrand by n order polynomial. Then the integral of the function is approximated by the integral of the nth order polynomial. If the area represented by fx dx a to b is divided into n strips, each of which h equals to b minus a over n. This is the formula to find h. So the formula for trapezoidal rule is given right here, whereby h over 2 bracket yo plus yn plus 2 bracket y1 plus y2 and so on. So I'll explain more about how do we apply trapezoidal rule by using the question in tutorial 4, question 1. The question is given by integrate 1 plus x squared to the power of 3 over 2 dx from 0 to 3. Firstly, let fx be 1 plus x squared to the power of 3 over 2. And since n is given to be 6, we could find h by using the formula that is given here. H equals to b minus a over n. B, we know it as 3. A is given by 0. N is also given, which is 6. So we get as 0.6. It's 0.5. Okay. And we'll tabulate a data. Given x and also 1 plus x squared over 3 to the power of 3 over 2. And the numbers on the x horizontal line is an increment of the h itself. So this would be 1, 1.5, 2, 2.5 and 3. And we substitute x to be one of the following here, and we'll get answer as 283, 5.86, 11.2, 19.52, and also 31.62. After which, by using the trapezoidal rule formula, 1 plus x squared to the power 3 over 2 dx given by h over 2 y0 plus y6 plus 2 bracket y1 plus y2 plus y3 plus y4 plus y5. This is y1, y2, y3, y4. This is y0. 1, 2, 3, 4, 5, y6. After h is given as 0.5, and we substitute in the values. 1.4 plus 2.83 plus 5.86 plus 11.2 plus 19.52. After calculation, we'll get it as 28.56. So, what are the advantages and disadvantages of trapezoidal rule itself? The advantages is that there can be any number of data points. And the next one is the data points can be arbitrarily spaced. And the disadvantage is the error reduces proportionally to the data spacing. That's all from my side. Thank you.